Hello everyone, here is the solution to this problem which I have posted on my Facebook page yesterday. 7 to the power of x minus 4 to the power of x equal to 33. By clear inspection, you can see that x equal to 2 will satisfy this equation because 7 to the power of 2 is 49. 4 to the power of 2 is 16. 49 minus 16 is 33. But how can we solve it algebraically? Let me show you. You see this? I know, for instance, if I have y to the power of x, this is the same thing as y to the power of x divided by 2 whole squared. Yes, because eventually this power of 2 will cancel this denominator of 2, leaving only x, y to the power of x. So I can do the same thing here. We have 7 raised to the power of x divided by 2 whole squared minus 4 to the power of x divided by 2 whole squared equal to 33. Now you can see we have difference of two squares. Power of 2, minus sign, difference of two squares. Remember, if I have a squared minus b squared, this is the same thing as a minus b multiplied by a plus b. We're going to apply the same thing here. So we have 7 raised to the power of x divided by 2, right? Then minus 4 raised to the power of x divided by 2, then multiplied by 7 to the power of x divided by 2 plus 4 raised to the power of x divided by 2. And all of this equal to 33. But if you observe, now we have factors, two factors multiplying each other. So we can find the factors of 33. Factors of 33, we're going to take positive values because from here, 7 is positive, raised to the power of whichever number, it will still be positive. So everything here is positive, right? And you know that this term here is growing faster than this. Therefore, we expect everything to be positive. So the factors we could have 1 times 33 or 3 multiplied by what? 11. But I'm not going to choose this one. Why? I know that this factor is bigger than this because we have minus here, but this is plus. It means this is bigger than this. Therefore, the two factors, I have to take the bigger number and relate it to this and smaller one to this one. But I'm not going to take this because if 7 raised to the power of x divided by 2 minus this equals to 1, it implies that the difference between this is 1, which is not possible. There's no way, there's no any exponent you can attach here such that the difference will be, 1. Let's assume x equal to 2. We have 2 divided by 2, which is 1. 1, 7 minus 4 is, 3. So I'm going to take this one. So this is 3 multiplied by 11. What does this mean? It means that 7 to the power of x divided by 2 minus 4 to the power of x divided by 2 is equal to 3. And 7 to the power of x divided by 2 plus 4 to the power of x divided by 2 is equal to 11. Now we can solve the system by adding the two equations. This and this are exactly the same, so we have two quantities. Two quantities of 7 to the power of x divided by 2. One is negative, the other one is positive, so this will give us 0. The other side we have 14. And if you divide both sides by 2, we have 7 to the power of x divided by 2 equals to 7. And 7 can be raised to the power of 1, which implies that x divided by 2 is equal to 1. If x divided by 2 is equal to 1, it implies that x equal to 2 by multiplying both sides by 2. Therefore, x equal to 2 is our valid solution. You may decide to take it from bottom to the top by subtraction, right? This minus this will give us 0. This minus this will give us two quantities of what? 4 to the power of x divided by 2. This minus this will give us what? 8. And if you divide both sides by 2, you have 4 to the power of x divided by 2 equal to 4 to the power of 1. The exponents are the same because the bases are the same for 4. So x divided by 2 in that case will be equal to 1 as well. Multiplying both sides by 2, you have x equal to 2. As simple as that.